Hello, everyone. Welcome to this comprehensive guide on running Hugging Face models in Google Colab. We'll be exploring 3 AI tasks: text generation, text classification, and image classification using 3 different methods: local pipelines with the Transformers library, API calls using Python's requests, API calls using the higher-level Hugging Face Hub library. By the end of this video, you'll understand exactly how each approach works. And if you're curious about customizing or fine-tuning your own Hugging Face models, I have 2 complete tutorials on my channel covering fine-tuning text generation and text classification models. Check the links in the description. The models we're using here are only for demonstration purposes. Feel free to swap them out for any other models you find on the Hugging Face website. Now, let's begin. First, we install 4 main libraries: Transformers for loading local pipelines, Requests to manually send data to Hugging Face endpoints, Torch, the deep learning engine behind many Hugging Face models, Hugging Face Hub, a higher-level interface for calling Hugging Face's inference services. Next, we create our personal Hugging Face token. To do this, log in at huggingface.co. Click on your profile, then Access Tokens. Choose Create New Token. Give it a name and set the privileges you need, such as Read, if you only want inference, or in my case, I will choose Everything. When you're done, click Create Token. Copy that token. Back in Colab, we store it as a secret named HF_token, so our code never shows it in plain text. For instance, we can retrieve that token in Python by calling userdata.get, referencing HF_token. That way, it's safe and out of sight. To start, let's generate text locally. We use the pipeline function from Transformers, specifying that our task is text generation. We set the model to something like OpenAI Community/GPT-2, which loads an old version of GPT that is open source and suitable for local testing. When we call the generator with a prompt such as "the future of AI is," we include 2 key arguments: truncation and max length. Truncation equals true, means if our prompt is too long, it'll be cut down to fit the model's maximum context limit. Max length equals 30, ensures the total output doesn't exceed 30 tokens, which prevents overly lengthy replies. This pipeline function then returns a list containing the generated text, which we can simply print out. This works best if you have a GPU in Colab, or you don't mind the time it takes to download and run the model. Now, to do the same text generation, but offload the work to Hugging Face's servers, we make an HTTP POST request using the requests library. We supply an authorization header that includes our token from Colab secrets, an API URL that points to a llama model on the Hugging Face servers. Then we define a payload in JSON format. The inputs field holds our prompt, for instance, "the future of AI is." The parameters field sets arguments like max length equals 30, which limits the generated text length to 30 tokens. Temperature equals 0.7, which adds moderate creativity to the output. Top-P equals 0.9, enabling nucleus sampling. So we only sample from the top 90% of probable next tokens. We then post this JSON to the model's API endpoint. The server responds with a JSON object containing the generated text. No downloads required, just an internet connection and your valid API key. As an alternative, Hugging Face Hub provides the inference client, which simplifies API usage. We create an inference client by setting its provider to HF-inference and passing in our token. Then, we define messages in a conversational style with a role set to user and content set to "the future of AI is." When we call client.chat.completions.create, we pass in arguments like model equals llama 3.2 3b instruct, messages equals our list containing the user prompt, max tokens equals 30, which is similar to max length, but for chat. temperature equals 0.7, and top-p equals 0.9, controlling creativity and how diverse the sampling is. Hugging Face Hub then returns a structured response. We simply print out the message field from the first choice. It's a cleaner approach if you plan on multiple chat-based calls. This approach can feel more seamless than manually crafting post requests calls. Next, let's see how we do text classification locally. We again use pipeline from transformers, but this time specify text classification as the task. We choose distilbert-base-uncaste-fine-tuned-SST-2-English, which is a sentiment model that detects positive or negative text. When we pass short phrases like I love AI or I hate AI, the pipeline function returns a label, for example, positive, and a confidence score. This local approach is ideal if you're performing repeated analyses in a GPU-enabled Colab environment. For text classification via the API, we do a similar requests.post call with an authorization header and a JSON payload. The payload's inputs field is simply our text, for example, I love AI. We again send this to the huggingface.co endpoint for the same Distilbert model. The response is a JSON list containing the predicted label, plus a confidence or probability value. This approach is particularly convenient if you want real-time classification in a minimal local environment, since no model downloads happen on your side. For an even simpler classification approach, Hugging Face Hub offers a text classification function on the inference client. We pass in two main arguments. Text equals our input sentence like, I love AI. Model equals the name of the sentiment model. The client then returns a small list indicating the label and score. It's a more direct method than manually creating a requests payload every time. Now, let's move on to an entirely different domain, image classification. Hugging Face isn't just about text. It supports vision models as well, like Google's Vision Transformer. First, I'll show you how to classify images locally. We again call pipeline, but this time specify image classification as the task and choose Google/VIT-base-patch 16-224 as our model. We pass in the file name. For test, we are using a local image named cat_sample.png. The pipeline loads the Vision Transformer weights and outputs a list of predicted labels, along with confidence scores. This is perfect if you want repeated or offline usage, but note that you do need to download the model into your Colab session. For remote image classification, we open the same image, but this time in binary mode. Instead of sending a JSON payload, we attach the raw bytes in the body of our requests.post call. The server expects image data, not text, so we pass data equals the file bytes. The server responds with an array of labels and scores. This is extremely handy when you'd rather not manage any local vision models, or if you only have CPU resources available. Finally, Hugging Face Hub lets us do the same classification with a single call. We open the same image again, read its raw data, and pass it as the image argument to the image classification method. We also specify the model to use. The client returns a neat list of predicted labels, again with confidence levels. You can see how Hugging Face Hub saves us from constructing raw HTTP requests ourselves. This is probably the simplest code snippet if you use multiple Hugging Face endpoints in your app. We've now clearly demonstrated how to tackle text generation, text classification, and image classification tasks using three powerful Hugging Face methods: the local pipeline, the Hugging Face API with the requests library, and the specialized Hugging Face API through the Hugging Face Hub library. Here's the bottom line. First, the local pipeline method is best when you have powerful hardware available, or if you need offline access and plan to frequently reuse models. It provides full control over your environment, giving you the flexibility for advanced customizations. Next, using the Hugging Face API with requests is ideal if you're looking for quick, straightforward API calls without adding extra dependencies to your project. It's perfect for instant inference, rapid prototyping, and quick testing. Finally, the Hugging Face API via the Hugging Face Hub library is designed specifically for users frequently interacting with Hugging Face models or datasets. It simplifies authentication, seamlessly integrates with Hugging Face's ecosystem, and makes your AI workflows smoother. Choose the method that best aligns with your project's needs. And remember, if you're interested in customizing or fine-tuning your own Hugging Face models, check out my other detailed tutorials, linked in the description. Subscribe, leave a comment, and let me know which AI topics you'd like to explore next. Thanks for watching, and see you soon.